Okay, so we just finished up week one, and now it is week two, and we're going into week two. So welcome back to ETEC 214. We just did a few warm-ups. You know, it's basically a lot of units conversion. Just to recap a little bit, I did emphasize the importance of starting out with pencil paper. You know, draw yourself a little picture, write out. I don't know if you've seen this kind of notation before, but it just means that energy is a function of these two variables. And we're going to see a little bit more of that in a second. And have you seen that notation before?
Somewhat, yeah.
Yeah, I mean, it's more like, you know, F equals F of X.
F of X is
exactly.
blah, 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 yeah.
Yeah. So, and in this case, and as if you're taking biofuels, or even if we get further into this course, you'll notice that there are typically more variables. It just gets more complicated, but it's a good idea to keep track of them. I also mentioned that every problem is sort of 3 in 1, where you're keeping track of your numbers, your powers of 10, and your units, canceling them through. I wrote some dimensions out here. We're not going to have to worry that much about the dimensions. That's more like a 101, getting the concepts driven home. So dimensions. It's more important to think of things more over here on the unit side. You know, what units we're using to measure these different dimensions: mass, length, time, volts, amps, etc.
Is there a good resource to, you know, like when we get further and things get more complicated, you know, like I struggle with what equation to even start with, you know?
Yeah.
We go to the engineering toolbox a lot.
It's not bad. Yeah, like down the road, we're going to use the ideal gas law a little bit. Some of these functions, you'll really have to just go back to the basics and write out, you know, what, you know, is this an energy equation? Is it a force equation? Is it a power equation? And as long as you got energy on both sides, or force on both sides, or power on both sides, you're most of the way there. You know, you get in trouble when you got like watts on one side and megajoules on the other, and time is nowhere to be found. So the nice thing about almost every single of these problems is energy sits right at the at the core. Like energy is like the gold standard, if you will. You know, it's what all the other you know, units are based on. So I think if you know, come back to energy, and we'll get into it later, whether it's, you know, mechanical or electrical. You know, there's a few hydro problems in here, so hopefully that's what Tuesdays are for, to at least give you, here's the equation you're going to use, right. And then we can work out the dimensions and units after. But yeah,
cool.
There isn't one resource for it. You know, I'd say a physics book would be a good place to start, though. You know, just grab a physics book. Hyperphysics isn't bad. The engineering toolbox is pretty good. I think, let me just see if they're still there. If we go back and look at the website, you get further down. I was posting lectures last year, so these are my YouTube videos. Yep, there it is from last year. Don't bother with the iTunes; they're dead. But Prius problem, motor belt fan efficiency. Yeah.
Cool.
Yeah. So they're not, and by the time we're done with the course, this will be fully populated. But I did have a few YouTubers out there. Okay, so we are in week 2. Let's just start from the top. Costs and benefits, different times, equivalent financial terms. This stuff is not easy. I'll just let you know, and it's getting a little bit late, but I think we can knock it out here. As I do have a really good spreadsheet on it that I'll just show you. I'm not going to share the spreadsheet online, but it is worth it to go through these things. It is worth the things we're going to worry most about are what the present value are. Yeah, the present value, the future value, and then the annuity values. And those are really the three financial functions. And basically what it comes down to is the problem of I've got a dollar in my hand, and the question is, do you want the dollar right now, or do you want it tomorrow? Almost everyone's going to want to say, I want that dollar now because I know it's going to be worth less tomorrow. And the idea is I can put that dollar to better, if I put that dollar to use right now, go buy myself some food, I'll be alive tomorrow to go get another dollar, basically.
Vicious circle.
Yeah. There are, it's so funny, I just got back from, where the heck was I? Oh, the Midwest. There's a guy coming back from Japan who is selling real estate in the U.S. to the Japanese because the Japanese yen is deflating. The Japanese yen will be worth like less tomorrow. It's kind of weird. A lot of these guys have put a bunch of money in their just cash under their mattresses, and they know that if they put that cash into like U.S. real estate, the real estate will become more valuable in the future. But if they just keep it as yen, that 1 yen is going to be worth like 0.8 yen in a year, et cetera, et cetera. It's just going to keep losing value. So he's over there sort of, taking their yen and turning it into land in the U.S. But so the point is there's this whole thing called time value of money, meaning that money's going to be worth less or more in the future than it is right now. So I'll let you guys take a look at this. Alt key, yeah, I was just using that a second ago. The Alt tab is fantastic. F to P, so this is future to present. Do take a look at that. I'll let you do that offline. Assignment 3. Okay. Problem 1. On one tab, create 6 separate equations. Man, I think I know I did a video of this. But here's the way to think about this. The three things I talked about, present value, future value, and annuity, are all right there. F, P, and A. And with 3 separate variables, there are 6 ways to combine them. Here's F and P. Here's F and A. Here's P and A. And then the reverse, the inverse. So, and there they are. F over P, P over F, F over P, P over A over P, F over A, and A over F. There are 6 ways to combine those 3 numbers algebraically. Okay. Now, and I think I actually found a pretty good financial. Usually I have you button. Future value. collegecram.com. What I'd like to be able to do. These functions are actually in your 101 textbook, believe it or not. Oh, I know how I found this last year. F over P. Yeah, look at that. Look at that. Boom. Okay. Oh. let's just look at that guy really quick. Yeah, it's just a big old table. We won't deal with that one.
I think that's actually in the middle shell.
Yeah, I want to go and look up the. Might actually be out there in. Let's go to Wikipedia and just look at financial functions. Oh, time value of money. Let's take a look at that one. Okay, this is a pretty good one. This is present value as a function of future value. And so what's in here is just the yeah, okay. So let's just do this one really quick. Just super simple example. Let's go to notes, file, save as, libraries, documents, courses, new 14, learning unit 1, energy and fuel tank. Let's start a new one. So we go right to that wiki page. Present value equals future value divided by 1 plus r. So what's that mean? Well, let's go ahead and copy it down. So present value equals future value over 1 plus r. Typically, it's easier to think of it the other way. So let's rewrite this as future value equals present value times 1 plus r. So if I know the present value of $1 is $1, I will put that in as $1. And the 1 plus r is the interest rate or the discount rate or the percentage rate. That's for r, the rate. So if the rate is, let's just say 4.5%, so 1 plus 0.045, that's 4.5%. The future value of $1 is, well, let's need a calculator for that. Let's see, did I do that right? 0.5. Why does that not seem right? That is 4.5%. Yeah. Yeah. Okay. Okay. Yeah. So equals 1.045. There we go. Yeah. So I'm going to have $1.04 in the future. I've not said when the future is. If it's if it's a 4.5% daily interest rate, that's how much it's going to be worth tomorrow. Now that's how much it'll be worth to the bank, because that's how much you're going to have to be paying them, because that's your interest rate on your loan. There's a different issue of whether the money itself is worth that from a sort of a comprehensive standpoint. This is just sort of money versus money. We're not like saying this isn't like money versus real estate or money versus kilowatt hours. This is just kind of money versus money as a function of time. Okay, so that's the first example. Let me dig. I'm going to go back into my notes from last year really quick. I think I might have had See if I had something. Yeah, I didn't really have a whole lot of extra writing down there. Let's just look at this guy. Okay, this is where we're going to get ultimately. This is what I came up with. But before we do that, let's just do a few more hand examples. Yeah. Okay. Here we go. Here's another example. So in the one we just did, there was only one unit of time. In this case, we're going to have n units of time. So the future value is going to be a function of the present value, the interest rate, which is written as I instead of R. But you can think of, interest rate, IR, take your pick. There's I or R, same thing, same difference. And then n is the number of years. So future value equals present value times 1 plus I. It's really what we just did, right? Except we just took it to the nth power. So let's just do it one more time by hand. So the future value equals $1. Again, let's do it for 10 years. 1 plus 0.045 to the, and I'll just put future value 10, and let's take that to the 10th power. Now, how do we get that into, well, let's see here. I don't know how good my calculator is. This little rinky-dink calculator on my computer. Let's see if we can do it. So, 1 plus 0.045 equals, so there's our 1.45. And now I think there might be a x to the y button here. There it is. X to the y. So now it's saying 1.045 to the 10th power equals $1.55. So I just did it without Excel on my calculator, kind of old school. You would not be doing that by hand or in your head. Sorry. if so, go join Mensa or a math program somewhere, or go on to Jeopardy. I don't know, but so looking at 155, $1.55. Okay, so they're super simple, going from present value of $1 to future value of $1.55 over 10 years at a 4.5 interest rate. What does that look like in Microsoft Excel? Okay, so this might look a little bit confusing at first. It's okay, because it is. But let's just try something here. I'm going to put in $1. I'm going to put in 10 years, and I'm going to put in 4.5%. Now, multiple choice. Which one of these contains the formula we just did? Bingo, this one right here. So let me see if I can make that a little bit larger. Blow this up. So what we've got here is I've done all 6 conversions in a single little table. And what it allows us to do is put in the amount. So let me just put in parens, and I already told you that the amount is either going to be the present value, the future value, or the annuity. It's going to be one of those 3 things. It's either going to be how much money you've got now in the present, how much money you've got in the future, and it's going to be, or how much money you pay every year. So that little block right there is going to be one of those 3 things. please do not copy my spreadsheet exactly. Work it through on your own, and yeah, anyway, yeah, it's just the way it worked out for me the first time I did it. This term in years, you can also think of it as the N that we were just looking at on the website a little bit ago. What's the N in years? And then the discount, this is the I or the R, right? The interest or the interest rate, however you want to think about it. I or R. Okay. So now what are we up to here? We've got 1, 2, 3, 4, 5. We basically have 6 variables. So we're a little bit out of the frying pan in the fire. But if we go back to the website where we just were, we can see that. So you've seen powers before. That's nothing too crazy. This one we won't worry about that one for now. Oh well, what you can see though is that this future value equation and this present value equation is just the same thing. They're just rearranged. They're just solved algebraically for each other. Those two are the simplest ones, the P versus the F. The trickier ones are the annuity payments, and again, there's nothing in this thing that you haven't seen before. I mean, that's just division, that's multiplication inside of parens, that's to the power. The trick here just comes in entering things into Excel. Because you can look at that, you can write it down, and you can get it right. So let's just hop back into Excel and see where these things. See how to enter one of these guys. So I'm just going to go with the one we already know, and the function. You can see that I've used B6, which was the value, in this case the present value, and I've used the Microsoft Excel function called power. Well, what goes into power? And if you haven't seen that before, here's what I suggest you do. Well, obviously we know that we're taking something to a power. That's what that means. So if you haven't seen it before, Excel is actually pretty friendly. Equals P, and it's going to give you every single function it knows that starts with P. O, don't need Poisson, I need power. And all of a sudden, okay, there's only one function that is power. E, R, and as soon as you open that paren, it's going to tell you the two things that it needs. And I'm sorry that's so small on the screen. It needs a number. Well, let's just do something we know. 2 and 3. 2 to the third power is 8. Close the paren, hit enter, and there it is. So we just demystified the power function in Excel. As we know though, what we're trying to do is this is the input. And I'll write it this way, out. It's output over input, are the way these things are designed. So P goes in, F comes out. So in this case, and again, remember this amount can be either the present, the future, or the annuity. So I'm just calling this the present. B6 goes in, and here's the function, to the power of 1 plus B4. What's in B4? Well, that's the interest rate. We already decided. To what power? Well, it's not 3. In this case, it's 10. And so with Excel, we got the exact same answer. Okay, so there's the F and P. It's relatively simple based on what we already wrote out here. So again, start with your pencil paper, use your calculator, and then take it into Excel for a double check. That makes sense, right, Joe? Thanks for hanging out so late with me.
Sure.
Okay. Now, the other ones get a little more involved, and here's the answer. I'm not gonna beleaguer this. I'll just let you know that there's a couple different power functions involved. They are not. There's no secret about them. If we go and look at putting in in this case the annuity is the input and the power is the output. This one's pretty involved too, but there's two separate power functions. Oops. This one's not too bad. This one's not too bad. The trickier ones are if you are working between an annuity and what the present value is. Let's just go and see at the website. I don't want G. I don't want a G. Future value of an annuity. Yeah, that's this equation is the one that you just saw in Excel for taking the annuity and turning it into a future value.
You just got to figure out how to plug that in.
Yeah, don't use the growing annuity. Just use the annuity. Oh, geez, they're all right here.
Oh.
Yeah. Wikipedia time value of money. So, like I said, these are not secrets. You're definitely gonna use this one. We've already seen it. Future is a function of present. You're gonna use this one, present as a function of future. You're just plugging in these top 6 formulas. Yeah, that's it. Those top 6 formulas, and these things have been around forever. They've been around since interest rates were in vogue. And again, when you saw those P's and A's, and there was 2 separate powers, one's in the numerator, the other one's in the denominator.
Gotcha.
Yeah.
Well, Excel will do all these for you.
Oh yeah.
Too.
Oh yeah. Well, yeah, but I think.
But he wants us to do it.
I would. I don't know if I've got them here. I might have even. I guess I still even. There are built-in. There are built-in functions, net present value, but I just kind of went at it old school with this. So, and once you've got it, I mean, that's kind of the nice thing is once you've got it in there, it's you can't really mess with it that much.
Well, that'll help.
Yeah, this is a good one. I'll even take that and post it to the website here while we're at it. We're logged in. Let's probably need to. Add any discussion. Time value of money. All. I recommend starting with the table. First 6 entries in the table on the following website. Oh, I might be able to do this guy. He's advanced editor. Okay. Oops, no. Font couleur. Show more buttons, please.
Buttons.
I want some more buttons. Link. Oh yeah, look at that. So you can paste that in or just click there and it'll take you back out to that wiki.
Cool.
Yeah. Time value of money. You know, I don't know. You gotta either love it or hate it.
Yeah.
Just the whole online thing. Like how easy was that to share information? Like it's just out there, you know.
It's a love-hate for me.
Yeah.
I like being able to set my own schedule, but sometimes you just get lost down the rabbit hole of the internet.
Yeah.
You know? I'm just like,
Yep.
God.
Yep. Yeah. Well, hopefully that little link puts you. I mean that's
Yeah,
you know just focus on focus on those guys. Put them in the computer hint. Okay, computer hint. Cash flow diagrams. These are kind of cool to look at. One thing in terms of the cash flow diagrams, what you'll see with those, or you might have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll have a timeline here, and what we're looking at. This will just be super simple, but let's just say I get. Let's just make it 1, 2, 3, 4, like $5 in year 0. There's no interest rate, and I'm gonna pay you back over 10 years. Well, I'm gonna pay you $1 now, $1 now, you know, in 4 years, or $1 in 2 years, $1 in 4 years, $1 in 6 years, $1 in 8 years, and $1 in 10 years, and then we're even, right? You gave me your $5 here, and there's 1, 1, 1, 1, 1, and this is with I equals R equals 0, and the annuity in this case is every 2 years instead of every 1 year. So it might seem kind of crazy at first, but once you've got these first couple equations down, it should make sense. Let's just go back into the Excel and maybe play around with one I came up with. So let's say you've got let's just say you've got $1,000, and let's just say that's the present value, and let's go for 10 years, and let's have the discount be 0. I think this might actually screw up because you can't divide by 0. So I'm just going to make it super small. So 0.1. So what this means, let's just look at these one at a time so we get a better feel for what the different ones are. What this means is if this is $1,000 now, and there's no interest on it, it just means that it's going to equal $1,000 in the future. That's all it means. It also means that if I've got $1,000 now, remember this is the input, it just means I need $100 back a year to call it even.
Gotcha.
So that was my $5 and $2 thing. If this is, if I'm going to give you $10,000 per year, that's the A. You're going to have, and there's no interest. You'll have in 10 years. You'll have $10,000. So if you're like scratching, oh my gosh, did I do this right? These are pretty cut and dried, simple. You got $1,000, no interest, and we'll run for 10 years. Same thing here. If this is the future value, if you want $1,000 in 10 years with no interest, give me $100 a year. So that makes more sense. Yeah,
Yeah, I was reading through that earlier, and just like,
Yeah.
what?
Yeah. Yeah. So what this says is that if there's zero interest rate, $1,000 now equals $1,000 in the future. You know, same difference. These two guys. $1,000 a year will give you. This is the weird one. $1,000 a year for 10 years is the same as $10,000 now. And that's the question. So what do you want? Do you want $10,000 now, or do you want $1,000 a year? Well, if you're not that responsible with your money, you might only want $1,000 a year. So, but if you're somebody who's investing, like, give me the 10 grand now, and I bet I can do better than 0% interest.
Sure.
Here, with the P&A, this just means that $1,000 now is the same as $100 a year for 10 years, and this one just means that if you're putting in $1,000 a year, in 10 years you'll have 10,000, and then this is just the reverse. If you want $1,000 in the future, put in $100 a year. So I think that's all there is for assignment 2. Let's just double check.
Oh, it seemed like there was.
There might be a few more. Okay, after to mess around with. Yeah.
Yeah, and there's.
Oh, here we go.
3, 4, 5, 6.
Yeah. Okay. This one will come. This one will be straight away. Number 2. Once you get the formulas in, that'll just pop right out. Salvage value of $7,000. Okay. The salvage value is the future value. It just means that it's going to be worth $7,000 in the future. The salvage value is the future value. Yeah.
So basically, once you get your table built, you should be able to copy it over to a different tab.
Yes, yes.
In the numbers.
Yes, exactly. So thanks for saying that. So this is the equivalent factors I built, and I think what I've done here is just more or less taken this whole sheet and I can just take this whole sheet, copy it, put it in a new sheet, paste it. It's all right there, and then just
switch your numbers.
Yeah, and just call it problem 2, problem 3, whatever. Yeah, absolutely. Do not don't build the sheet again. Yeah, the point of pushing through the pain on this first sheet is once you've got it, then you just reuse it. And I think what I've got here is yeah, I think in this case this might even be that one problem we just looked at. I just got rid of the extraneous information. So, and I don't know if that's the right answer or not, but that's kind of the way, the same thing here. I just kind of started getting rid of stuff. So
makes sense.
Yeah. So let me just see what other kind of snags there might be there. What is the present value of problem 3? So again, go back to the basics and say, what do I know? Well, this is the discount rate. That's your I or your R. What's this thing? Well, that's the future value. What's N? Well, it's 15. Every one of those numbers is going to have to fit into one of those slots.
Right.
$20,000 when purchased, that's the present value. Maintenance, that's basically your annuity. You're gonna spend $1,000 a year. Device will generate revenues. So this is sort of your negative annuity. That's how much you're losing. The 5,000 is how much you're getting.
Right.
So you might just run them as 2 separate problems and add them together. In the 5 years, again, so there's your future value. There's your I or your R. Yeah. Oh, please, like I just said, please treat the cost and revenues separately. So what I would suggest doing there, take this thing, copy it, and just paste it on the same sheet. Just run them parallel with each other. And then you can at the end add them together. In this case, you'll have to go back and say, okay, 15 cents per kilowatt hour, how many kilowatt hours did it make? Just turn, dollars per kilowatt hour and kilowatt hours into dollars. That'll be your annuity. It sounds like this is a little bit of a trick question. So what are we missing to calculate the total present value? So just, take a look at that and go through it. And again, don't let this stump you too much. If there's something missing, just make it up and say this is what the answer would be if I knew it.
Okay.
So, get creative, take it one step further. Don't let it beat you up. At least one spreadsheet, the PDF, take a review. Yeah. All right, that's week 2. I think we're caught up. These are some good problems in there because if the cost of energy is going to change too over time. I mean, this is just kind of getting you going like, oh, really? So yeah, if the cost of gas goes up or oil goes up or coal goes up, but the cost of solar panels continues to go down, the amount by which your ultimate payoff changes gets even better. And that's not even built. We didn't do the G or the growth on this, but that's kind of how, this is just, like I said, pretty good start into this world because, almost all these decisions do come down to some kind of money.
Well, working at the co-op there, they've got a pretty interesting financial, like the money they make today is for stuff they need 50 years from now.
Mm-hmm.
It's pretty. Dan explained it all to me, and I was just like,
yeah. What I don't get is some of these companies. I heard Amazon finally broke even. They've been just working on debt for years. Yeah.
Wow.
Where people are like, okay, just keep going. Eventually you'll and I mean, I don't know. You kind of look at. I mean, my mortgage. I don't really own my house. I mean, maybe eventually I'll break even. We'll see. But, yeah, in a lot of ways, I just got done reading the book *Sapiens*, and in a lot of ways, money is just sort of, banked money is just kind of faith in the future that it's going to be there. It's going to come back. It's going to keep working. Yeah.
Hopefully.
Yeah.
Well, thanks. That was makes me feel better.
Yeah. Me too. So when you guys are panicking, I feel terrible. Save that. Save as. Time value money. Nice. All right. Well, 44 minutes, but I think it was worth it.